Okay, so in this problem, we have styrofoam dropped from a height of 2.00 meters. Let's write that down. It reaches terminal speed. The acceleration is g minus bv, where b is some constant, and then acceleration is proportional to the velocity. So after following the half meter, it reaches its terminal speed. So let's just draw this out. So here's the styrofoam, and then it reaches VT, and then it's, let's just call this, I don't know, what should I call this? I'll call this HT, I guess, to associate it with the height that it falls before it reaches its terminal velocity. And then that's 0.500 meters. And then to go from this point to the ground, it takes 5 seconds. So I'll call that T. And then we want to get the value of the constant B. Okay, so lots of little pieces to the puzzle. And we want the constant B and then the acceleration when T is equal to 0. So instead of like focusing on what we want, I'm just going to figure out like what we could find using this information. So we know that this whole height is 2, and then this is a half equals 0.5. I think I'm going to work down here. I think that's where we have the most information, because we know it falls 2 minus 0.5 is 1.5 meters. So this section is 1.5 meters. And we know that it's at a constant velocity of whatever the terminal velocity is. So we know we can say VT is equal to 1.5 meters divided by 5 seconds. So that's 3/10. So that's 0.3 meters per second. So that's its terminal velocity. And then, okay. So now maybe we can come back up here. And then we know that once it reaches its terminal velocity, so if V equals VT, then A is equal to 0, right? Like that's kind of the definition. So we know G minus B VT is equal to 0. And there we go. We get B is equal to G over VT. And so we're going to do 9.81 divided by 0.3. So that's 32.7. What are these units? So meters per second squared. I'm going to just write this out. Meters per second squared divided by meters per second is going to give us inverse seconds. So that's what I get for B. And we want the acceleration at t equals 0. So that's the answer for A. The acceleration at t equals 0, the velocity is 0 at t equals 0, so the acceleration should just be 9.81 gravity. Unless I'm missing something. And then now we want the acceleration when the speed is 1.5 meters per second. And so we can just use our formula for that. So A is equal to G minus B. V, this case, we're going to say V is equal to 0.15 meters per second. So let's just plug and chug. We know B, 32.7 inverse seconds. So we can just do 9.81 minus 32.7. divided by, or no, multiplied by the velocity, and the velocity is 1.5 or 0.15. I get 4.9 meters per second squared. Yeah, and then how many sig figs? That would be 9.1.